Welcome to this video, and in this video we're going to have a look at the puzzle of these blue straggler stars in globular clusters. So we're going to explain why they're there when they really shouldn't be there. So first, globular clusters are these dense clusters of stars that typically orbit around the outside of spiral galaxies. They don't really have any gas in them, they're quite densely packed, and they're full of pretty old stars actually, so they're quite old red stars. And they orbit these galaxies. So they don't have any gas in them. Now, because they are old objects, they don't have any gas, there's no way for them to create new stars. They can't undergo new star formation, so they're left with an old population of stars. So what we should find is that they are all red stars, because as stars age, they get redder. So there's no gas there to form. They should have a population of only red stars. There's no way for new stars to form, but you can probably see, looking at that particular image there, that there are blue stars in there. So we can see these blue stars, and we call these kind of blue straggler stars. But as a general rule, bluer stars, well, they're hotter, they have a higher surface temperature, and that relates to their mass. So the more massive they are, the higher their surface temperature on the main sequence, and that means that they actually don't live as long. So the more massive a star, the shorter its life. So if we have a star that lives not as long as a smaller star or a redder star, then seeing them here obviously raises some questions, because it means they've got to be young. It means something must have formed them relatively recently compared to the other stars, because they don't live very long. So on the HR diagram, you've got the main sequence down the middle, the diagonal there, and where they sit on that relates to their mass. So the more massive they are, the higher the surface temperature, and again, that also relates to how long they live. So you get these blue stars here, but in time, they themselves would become redder as they age. So as they age, they kind of move off to the right-hand side of the HR diagram, unless it's a hypergiant, and then it might not do so. But most of your blue stars are likely to go through a redder phase. So again, that tells us that they have to be fairly young to have a blue star. Now, the population of the cluster itself, so that's the general population of stars in the cluster, is smaller, older stars. So they would reside on this part of the HR diagrams a bit further down. They've got lower surface temperatures. They're a bit more evolved, so they have already moved to the upper right-hand side of the HR diagram. So the whole population of the stars is older and redder. And that's why we call them blue straggler stars, because they are outside of that general population. They're bluer than the background population. So how do they actually form? Why are they there? Well, because they're fairly, or not fairly, but they're very densely packed stars in these clusters. They're very close together. You have many enclosed binary systems, either orbiting a common center of mass. So you've got these two older stars that may be orbiting fairly close to one another, and they can in-spiral and collide. And when they collide, they create a new, young, larger blue star. So you have these two older stars, old red stars, they collide and they form a bigger single blue star, which is obviously younger. So we don't need to have gas to form these. It's actually from the collisions of these older red stars that give rise to these blue stars in these clusters. It's not just confined to globular clusters. Open clusters, which are not as densely packed as your globular ones and a bit more open, you also get blue straggler stars there. And if we think about what the definition of that is, it's a star that is bluer than the general population of the cluster itself. So you can see some blue stars here in these open clusters. So it's not just confined to globular clusters, but it can happen in open clusters as well. So thank you for watching, and if you enjoy, you can check out some of the other videos.